Hey everyone, it's Justin again. In this lesson, we're going to be expanding on all of the area knowledge you've built so far in this unit to discuss how to find the area of figures when they're in the coordinate plane. By the end of this lesson, you will be able to find the area of figures in the coordinate plane without being given any segment lengths. First, we'll discuss how to find segment lengths from figures in the coordinate plane. Next, we'll complete 2 example problems. We've spent this entire unit learning how to find the area of all different kinds of shapes. We found area when we've been given the necessary segment lengths, and we've also used methods like the Pythagorean theorem to find missing segment lengths. In this lesson, we're going to be using a new method to find segment lengths: the coordinate plane. We can do this in 2 ways. First, if a segment is perfectly horizontal or perfectly vertical in the coordinate plane, then we could just count the number of units that it spans to find its length. But what if a segment is diagonal in some way? How can I find the length of a segment like this? Yes, as long as we know the coordinates of the endpoints, we can use the distance formula to find the length. Let's see what this looks like in practice. This example says to find the area of trapezoid TRAP, which we can see graphed on the coordinate plane. Let's start with our area formula. Since we're finding the area of a trapezoid, what's the area formula for trapezoids? Yep, it's base 1 plus base 2 over 2 times the height. Which segments in this trapezoid represent the 2 bases and the height? Remember, the bases in a trapezoid are the 2 parallel sides, so those would be segment TR and segment PA. The height is the perpendicular segment between them, so that would be HG. These are the 3 segment lengths that we need to find the area of the trapezoid. So, how do you think we could find the lengths of these segments? We can always use the distance formula to find the lengths of these segments. But did you notice that all 3 of them are either vertical or horizontal? This means that we can just count the units from one endpoint to the other to find their lengths. Either method will work, but counting the length is going to be quicker, so I would definitely recommend doing that. Pause the video now and find the lengths of all 3 segments. I can see that the length of TR is 1, 2, 3, 4, 5, 6, 7 units. So let me just substitute that into my area formula, and we'll do PA next. Ooh, PA is a long segment. I could count this by ones, but that would take a lot of time and I might lose count. So let's try to be a little more efficient with our longer segments. Do you notice that on our graph there are tick marks here every 5 units? We can use those to help us. If I jump from P to the first tick mark, that's 4 units. And then I'll make a big jump to the y-axis, which is 5 more units, bringing us to a length of 9 so far. Then I can jump to the next tick mark, which is another 5 units. That brings us to a total length of 14 so far. And A is not past the next tick mark, so I'll just count out the last 1, 2 units, bringing me to a total length of 16 units for PA. Let me substitute that into the formula, and then we'll do the last one. The length of HG is 1, 2, 3, 4, 5, 6, 7, 8. 8 units. Once I substitute that into the formula, all that's left to do is simplify this calculation. Don't forget your label. Since we weren't given any specific measurement, we'll just say that the area of trapezoid TRAP is 92 square units. Let's do one more. This example says to find the area of parallelogram GRAM, which we have plotted on a coordinate plane. Before we worry about the coordinates, how do we find the area of a parallelogram in general? Yes, our formula is area equals base times height. The base can be any side of a parallelogram, and the height is the perpendicular distance between the base and the opposite side. Do you have any idea which segments we can use for the base or height? Well, we have to use PR as the height, since it's the only segment we've been given that's perpendicular to one of the sides of the parallelogram. That means that either MA or GR could be the base. Since this is a parallelogram, they're congruent, so it doesn't matter which one you choose. I'll be using MA. Now we know which segments we need to find the lengths of, so let's go for it. Both of these segments are on a diagonal, so I can't easily count how many units their length is. Instead, we'll have to use the distance formula. Pause the video here and find the length of MA first. Point M is at -3, 3, and point A is at 0, -6. I'm going to use M as x1 and y1 and A as x2 and y2. If you chose to substitute them in the opposite way, that is totally okay. You will still get the same answer. Now that I have my points, I can substitute my coordinates into the equation, simplify everything under the square root as much as possible, and then simplify the square root to get a length of 3√10 for segment MA. Let's repeat that process for our height. Why don't you pause the video now and find the length of PR for yourself? Point P is at -1, -3, and point R is at 5, -1. I'll be using P as x1 and y1 and R as x2 and y2. If I substitute and simplify as much as possible, I get a length of 2√10 for PR. Now that I have my lengths, I can multiply base times height to get the area of the parallelogram. When multiplying terms with square roots, you want to multiply the whole numbers together to make a whole number. In this case, 3 times 2 makes 6. And then you want to multiply the numbers under the square root together to get your product under the square root. In this case, √10 times √10 makes √100. Do you see anything else I can do here? Yep, I can simplify √100, and that'll actually just make 10. So I can continue simplifying by doing 6 times 10 to get a final answer of 60 square units for the area of parallelogram GRAM. While we only completed one trapezoid problem and one parallelogram problem together today, you now know how to find the area of many other shapes, and these will all be included in your practice game for this lesson. So make sure you have your notes handy for all of the area formulas that you've learned so far in this unit. Although the shapes and area formulas may differ, you can use this same process for any shape that you know the area formula for. You'll use the area formula for the correct shape, identify which segment lengths you're going to need to use in the formula, and then you'll find their lengths by either counting their length if they're vertical or horizontal, or by using the distance formula. When it comes to counting lengths, you can use whichever method feels best to you, whether it's counting by ones or by using larger increments. Being accurate is what's most important here, but try to be efficient. Timing is particularly important for things like the ACT or the SAT, so it's good practice to try to get used to methods that allow you to work more quickly. Good luck on your practice, and I'll see you next time. Hey.